Welcome everyone, I'm Arlon from FHIR. I will be doing the moderating and the QA at the end, but I'm here to give the floor to Peter Jordan, all the way from New Zealand.
All right. Okay, thanks. Can everyone hear me okay? Fine. Good morning, everyone. Good to see you all here. I hope you're all enjoying this wonderful event as much as I am. I'm Peter Jordan. I live in Hamilton in the North Island of New Zealand. I don't have a New Zealand accent. I have an English accent when I can actually speak. I spent half my life in the UK and half in New Zealand. I'm currently the board secretary of HL7 New Zealand, past chair. I'm a digital health architect, but that's sort of a nice title. I'm fundamentally an HL7 standards implementer and SNOMED standards implementer. And I've been implementing HL7 standards on and off for 30 years. I'm a co-chair of the SNOMED on FHIR advisory group. I love FHIR. My chief interest in FHIR are terminology, the IPS, and medications, which is what I'm going to talk about today. So now that's disappeared. It's back. That's good. It's surfaces up. So basically what I'm talking about, that's all right, I'll give these people a chance to sit down. Hi, Andrew. Is that I've worked on the e-medicines team at Health New Zealand and its predecessors for about a dozen years, and it was decided to create a national medication repository using FHIR based on data in our transactional e-prescribing system. So I'm going to provide a little bit of background, talk about the solution design we used to move the data from one environment to another, the major challenges, what worked, what kind of worked, and what was difficult, and some key findings, and a bit of Q&A if we've got time. Oh, I'm going the wrong way. Oh. So the background here is we have a national e-prescribing service established in 2012. It's used by 100% of community general practitioners and pharmacists, and we've got increasing uptake in allied professionals, outpatient clinics, specialists, and we're now moving to inpatient prescribing. So roughly, it's based on bespoke XML messaging with CDA documents as the main clinical payload. And at the moment, we probably, on average, have about 2.5 million prescription items loaded to the transactional repository per month, which is a lot for a population of only 5.3 million. Maybe we're not quite as healthy as we sort of like to tell the world we're very healthy people, but maybe not. It's predicated on a common data model and a tooling component, a toolkit we created for all CDA implementations. Initially by Dr. David Hay, who was ironically also one of the leading FHIR evangelists. I think he was one of the original 12 apostles from Graham. And this is used by all the participating systems, presents an application layer object model which they populate, and the tooling creates the rendered artifact CDA documents. And it's a closed transactional system. And we wanted a system to take that transactional data and put it in a clinical data repository as a trusted source of truth for all prescribing and dispensing data. And we wanted a standards-based API for both clinicians and consumers, and something that will be future-proof because we've got an ever-increasing number of use cases for medications data. So here's basically the solution design. If you're interested in the slides, drill down into that sequence diagram, because this basically is how we map the data from one transactional repository to a clinical data repository. So we decided to use, for FHIR, obviously we chose FHIR as a solution, and we chose to map the CDA documents to medication request and medication dispense. And we've done that through a FHIR mechanism. So we used the structure map resource and the transform operation on the structure map resource. So basically, we pass the CDA in a FHIR binary resource, base 64 encoded version of the CDA in a binary resource. And internally, the structure map that maps from the NZEPS data model. It parses the payload into this data model that we've used for a dozen years in the toolkit, and it maps that to the FHIR information model, which is represented by the .NET SDK, which FHIR provide. So it's application layer modeling to model rather than rendering formats. And I think that makes life a lot easier. I really think it's hard if people, for example, who are trying to map CDAs, raw CDAs or raw V2 messages to FHIR. It was decided the deployment platform will be Microsoft Azure on FHIR. And somewhat controversially, we created two different stores, a cold store and a hot store. The hot store is for busy transactional requests, and that only holds 2 years' worth of data. The whole of history of NZEPS, 15 years worth, is in a cold store, and that's for bulk queries, analytical queries, and that's represented in a fashion that people can query using more, what to analysts and more typical tools are Python, SQL. Right. So, I'm going to focus a bit on the challenges. The tech's fine, the FHIR stuff works perfectly, of course, because FHIR is such a great standard and flexible standard. But what were the actual challenges in practice? And a lot of this is an exercise in some ways in trying to turn water into wine, hence the graphic. You know, they're information model variances. I mean, everyone will find this if they're mapping data from other formats to FHIR. It's particularly status, or status as the Americans would say. Status codes are a big variant. We have some strange bespoke status codes in the New Zealand e-prescription service, like repeats remaining, and different versions on what is an active prescription, which seems very strange, but some people stick to their guns and say the prescription is only active if it's never been filled, whereas most people's perception is a prescription is active if it still can be filled, i.e. if there are refills remaining. So we have these terminology variations. What's the difference between a repeat and a refill? And that's obviously, that's confusing. Drug coding issues, obviously. Fortunately, we have a New Zealand medicines terminology, which is an excellent terminology, and that's used ubiquitously in the NZ prescribing service. Missing data is a problem. Generally, all you can be absolutely guaranteed of getting on a prescription is what's been prescribed, the patient, obviously, what's been prescribed, when it's been prescribed, by whom it's been prescribed, the medication, and the instructions. And that's all you can be guaranteed. Getting atomic dosage information is not always feasible. Sometimes it's very complex. Sometimes the participating systems don't fill in atomic dosage data. And we get incorrect data as well. My favourite word, quantity. People have data elements in their system called quantity. Well, quantity in health informatics is a data type. You know, what you're dealing with, a supply quantity or a dose quantity, and that's quite significant, as we all know, the difference between the two. Dispensing data. This raised some problems. When you're moving stuff from a transactional system to a clinical data repository, the transactional data the transactions aren't all complete, the script isn't complete, so you've got to update it. So you're faced with, in IT terms, a replication situation. So how do you uniquely identify records so you overwrite them when you need to, because the clinical data repository doesn't keep history, it only keeps the current version of the medication request or dispense. So that was very easy for medication requests because we've got a unique, immutable identifier for every prescription. But the dispensing was more difficult because we tried to think what's immutable about a dispense that we can use as an identifier. Because the feeding systems don't have GUIDs that we could use for replication. If they did, it would be easy. And And we found out there was nothing immutable in a dispense. They can change anything. And also that we were trying to use the date time to the nearest second, and then we found we had things called group dispensings where multiple doses of methadone, for example, are prepared at the same time and had exactly the same date and time. And eventually we persuade the pharmacy system vendors to stop, not quite to do that, but that was a problem. And also they can change the dates, they can reverse dispensings. So they'll prepare date, when they prepare the medication, that's when they feed the data to the transactional repository. If it's never picked up, they have to reverse the dispense. That caused some issues. Obviously, patient confidentiality issues. And the fact that much of this data is entered in quite busy environments, quite hectic environments at community GPs and particularly pharmacists, huge queues, etc. And the overall culture, this is pervasive in health information, about the downstream uses of data not being sufficiently valued by, well, in this case, prescribers and dispensers, but by anyone who's entering the data. They don't see the value of the downstream uses of this for analytics, service, utilisation, all the fantastic things you can do with data and stuff that we heard Dr. Rooker speak about this morning. It's a hard sell to some clinicians to really be concerned about anything other than what's in front of them. So, to take a sort of an analogy for one of my favourite movies, the good, well, obviously, having a FHIR standards-based information model and persistence format is fantastic. Whatever one may think of what persistence formats, having a standard representation of a health information model in a persistence layer is critical. Standards-based API to handle all common queries, fantastic. And our New Zealand Medicines terminology, which is a wonderful piece of work and maps to SNOMED, medicinal product, etc. So what was bad? The FHIR resource model isn't ideal for all use cases. Maybe people who like relational databases, dealing with multiple elements with different multiple types is quite difficult. I mean, to some extent, I think that's a question of education. I mean, people are used to relational data and not so much data rendered in FHIR resource format. So we found we probably didn't educate our clients enough about FHIR before we said, hey, here's the IG, that's base camp, your IG. Now, are you going to need ropes and Sherpas to get you any further, or can you actually go, get up there on your own? People querying just on medication dispense, and we've tried to say no because you need the prescription. The prescription carries the context. I mean, in a good case, it'll have the coded indication for prescribing, for example, or the overall status of the script. And we hit some limitations, which luckily Microsoft fixed on the underscore include and underscore reverse include, rev include search parameters. And I think in a FHIR query, you can stipulate how many resources you want to get back, 50, 100. But if the source, main source of the query is medication request, that's how many medication requests you'll get back. It doesn't cover how many dispenses you'll get back. And there was a limit of 100, I think, and they've raised that to 1,000, very kindly, very responsive. And ugly, I suppose, 18 extensions on medication request, because in a CDR, you're not going to create, I don't think, task resources. And if you were having a transactional system based on FHIR, a transactional e-prescribing system based on FHIR, you'd use task resource extensively. But we were saying it's a CDR, do you really need to know all the transactional elements? Well, yes, we do. We need to know this, we need to know that. So 18 on medication request, 6 on medication dispense. And just getting people to appreciate that you're storing incomplete transactional data. So mean, the average life cycle of a script, well, the maximum is 3 months for most scripts. Some it's 6 months, and some oral contraceptives it's 9. Government has just announced they're going to have year-long prescriptions. So that means, you know, a script could be alive for a year. And people want the latest information from the CDR. They don't want just complete transactions. They want whatever's there. What's the patient currently taking? Or what's been given to them to take? So the key findings, I think, the importance of information models as a means of mapping between two separate health information exchange and rendering formats, critical role of international standards in creating software components for health interoperability solutions. Without our CDA toolkit and the SDK from FHIR, that would be really hard. I mean, I live as a developer inside that SDK. This is probably not news to anyone, but semantic interoperability is highly dependent on the quality of data in the source systems. And that's probably the number one thing that we need to address to make real progress. Next steps, integration with the New Zealand formulary. The New Zealand formulary has a FHIR API, and that's the source of truth for all medication resources. So within dispense and request, we have codable concepts. I guess that will have to change to codable references in R6. But all the information about the medication, active ingredients, its relationship with other medications in the same family. Because prescribed medications tend to be generics in New Zealand, and dispense are all trade products. Inpatient data, more complicated dosage regimes, titrations, etc. Medication administration data, I think that's going to be very interesting when people start wanting to put that in a repository. Could blow the size of the repository out exponentially in inpatient settings. Medication statement, I think that we didn't get round to publishing the consumer API because of funding restrictions, and I think we need to revisit that. I don't think we want. I think we should best serve consumers by giving them medication statement resources rather than all the individual requests and dispenses. I can be contacted any time on those addresses. I'm on Zulip a lot of the time, maybe different times than when you guys are on. But and there's a bit of time for a Q&A. Have I asked that question just in case no one else asked the question. So it's not harmful to question oneself sometimes, I think.
Nice. Thank you, Peter. Are there any questions?
Rick?
Thanks, Peter. I was curious about the transform. I know this is a bit technical, about your structure map and your transform. Was that sufficient to sort of for an off-the-shelf system to convert from your source data to FHIR, or did you have to kind of hack it?
Well, it's a little bit of a facade. It's really, there's a lot of bespoke code underneath that. All the mappings aren't stored in a structure map resource. I'll be honest about that. I mean, I wrote the thing, but yes, it was a lot of bespoke code. It's all documented. I mean, element by element in a big data model, and both ways as well. It's documented. But yeah, I didn't use the resource would have been massive if I just used the resource. But we just used that as a kind of as a facade layer, basically, because it's an easy way for. The component that does the mapping is housed inside the Azure on FHIR environment that our partners, Whanatahi, one family, that means in English, they're our long-time partners on the prescription service, so they wanted to house it, and it's a cut-down version of my FHIR server that they use, behind a firewall and everything. And that was the easiest way for them to communicate was via FHIR API call to pass the data and get the bundle back, and then they store the bundle.
So you're using that as a standard facade onto a custom system.
Yeah.
That makes sense.
Yeah. Good question.
And does it use the FHIR mapping language as well with the
No,
transform?
no. I'm sorry. No, it doesn't use the FHIR mapping language.
Thank you. I think particular thanks for exposing some of the warts at the edges and what the difficulties were. I just wanted to explore one of those a little further. I'm glad to see you bringing out the trade-off between simplicity of resource structure and extensions. So I think that's one sometimes gets glossed over or purist positions are brought forward. But I think that's certainly when we're dealing with existing data and data quality issues, that's really important. Just wondering if you could open that out a bit further for us from your experience on this project.
Yeah, I mean, I tried hard to convince people to use only the FHIR, the status codes in medication request, and I got pushback on that. I got pushback on several things because implementation experience. This thing's been in production for 2 years, and I've probably made 2 significant changes to the mapping, not additive changes, because they wanted more extensions. They want the New Zealand e-prescription status. They want to see repeats remaining, which is it's a calculated field. It shouldn't be a status, but in my opinion. But yeah, it's difficult calibrating user expectations. We've got a big community. We've got about 25 suppliers who feed information into this, plus people who have been used to extracting the CDAs via a data feeder service and presenting information to hospital systems, and they wanted a lot of things. And every time I thought we should weed them away from this, really be as standard as possible, and they would just say no. But there's a lot of education, and I think I'd say up front, educate your FHIR clients. You can say, here it is, but unless they're experts and they can get up the mountain on their own, they're going to need guide ropes and support to get them to that stage. Does that answer you? Is that a question? That's a nice question.
Okay, this concludes. Time for coffee. So give another warm applause for Peter.